So let's further explain what a quadratic is. Problem 5. Let's write an example of a trinomial. So a trinomial is something that has three terms. So for example, this is a trinomial. We have here one term and a second term and a third term. We know what a term is because it's separated by what we call an operator. So the addition or subtraction signs are operators. So these operators separate terms. And since we have two operators, then there's one in the front of this operator, one after it, and then one after it for a total of three terms. However, that trinomial was not quadratic because we needed it to be to the second power. So for example, if I write something like this, this is a quadratic trinomial. Notice that there are three terms, right? We have two operators, a minus and a plus, and that means I have 1, 2, 3 terms, and the highest term has a power of 2, which makes it quadratic. So in order for something to be quadratic, the highest power has to be a 2. Nothing more, nothing less. Now this is a quadratic trinomial or a quadratic expression. If I wanted this to be a quadratic trinomial equation, I would have to make it equal to something. So again, an equation is an expression that has an equal. So we're setting two expressions equal to each other. All right? In other words, this is a complete mathematical sentence. It's not a fragment. It's complete, it's whole. And that's because we have this equal sign. So in order for it to be an equation, there has to be an equal sign. A quadratic equation is a polynomial meaning that there's multiple terms, equation of the second degree. And sometimes it is considered as a trinomial, right? A trinomial with an equal sign. In other words, we're defining a quadratic equation. The standard form of a quadratic equation is as follows. We're not going to be doing A, B's, and C's, but what we're saying is that the coefficients, and you might want to put this in your left column, that the coefficients of a quadratic are A, B, and C. And this will be very useful when we do various forms or techniques of factoring, including the quadratic formula, which has A's, B's, and C's in it. So just be aware that this is a standard form. Notice that it's in descending order, like the higher power comes first, and then the next one, which is a 1, and the next one, which is a 0 power, right? And then there's an equal, and then there's 0. Okay, and that the coefficient is the number in front of the letters, are A, B, and C. So we're not going to necessarily solve some of these. I wanted to take some time to think about, to observe, and to reflect how to work on these and what they are. So if we look at A, for example, A is not quadratic at all. There's no second power. It's a pretty simple linear equation. But how would we solve x? Remember, to solve means to get the x by itself. Okay? So we would go ahead and add 3 to both sides, just like we've done in pre-algebra. And we get that x equals 3. So problems like these, which are going to show up when we do quadratics, are easy enough because they're either a 1 or a 2-step problem, right? We either add or subtract, multiply or divide to get the x by itself. But be aware that A is not quadratic. And folks, you are highly encouraged to write down words because I'm going to be asking you some of these words on the assignment. Part B. You'll notice that we have parentheses, and we have 2 of these. Now you're thinking these are not quadratic. Well, if you were to FOIL or distribute these guys or use a box, you would get the original quadratic trinomial that it came from. But this is already like the second to last step before you do something. What I'm telling you right now is don't FOIL this, don't box it, don't distribute it. This is pretty much almost done. When I see a problem like this, what you need to do is, you're going to want to write this down. You're going to want to separate and solve. So in other words, I'm going to separate these. There's the x plus 1. There's the x plus 5. And they're both equal to 0. So we've separated these, and then we would solve them like we did part A. Okay, now we're going to notice something here in a bit about quadratics and how many answers they have. But part B is separate and solve. Hopefully writing down words, right? Part C. Well, you don't see the two sets of parentheses, but I'm going to suggest to you that this is also a separate and solve problem because I have an x on the outside and it's being multiplied by x minus 6. And they're both equal to 0. We already have one of the answers. One of the answers is x equals 0. We just have to solve the second one to get the other value of x. So C is also a separate and solve problem. Part D is definitely what we're going to be seeing a lot of in this class. As far as quadratics are concerned, this is a classic quadratic trinomial equation. You'll note that it's in standard form, right? A is 1, B is 2, C is 1. Those are the coefficients. But those aren't the answers. So this is a trinomial, and what we would need to do with it is we need to factor it. And I'm not going to do that right now. I just kind of want to show you, give you a feel of when you see certain problems or certain setups, how should you approach them? So if you see something like part D, you would need to factor it. If we were to look back at what we wrote for problem 5 for a quadratic trinomial, we would have to factor that, right? When we look at this standard form right here for problem 6, we would have to factor that, right? And we will spend a generous amount of time in this class discussing possible ways to factor it. Part E. Notice that it's not a trinomial. You don't have 3 terms. You have an x squared and a 1, right? Because I only have one operator, one plus sign. So E is rather interesting when we see problems like this. In this case, we would move this one over, and then we would square root. So just to kind of give you a look of what that looks like, I would subtract 1 from both sides. And then I would square root both sides. If I square root a square, I just get the inside goodies. If I square root a number, I get a plus or minus, which we'll talk about more in detail. However, I do want to kind of bring back some PTSD. And by definition, what is the square root of -1? It is a complex number. It is an imaginary number. It's I. Okay. So what we're saying is that there's 2 answers technically, right? There's a plus or minus. Either the answer is positive I or the answer is negative I. So for E, we got 2 answers. Now, of course, we're going to develop this idea a lot more in the future, but I just wanted to show you some of the techniques, right? So if I see something like E, where there's 2 terms, you're going to want to, and here's the words you want to write down, you're going to want to move the number over and then square root to go ahead and solve to get the x by itself. So in problem 8, when we have a quadratic equation like this and they ask us to find the roots, roots are another way to say the solution, the answer, to solve. Okay, so they're asking us to solve. And again, we're not going to get into the details of how to solve problem 8. All you know at this point is you're going to want to factor, right, as we discussed previously. But a root is a solution to a problem. So if we found a solution, which means we found a root. Sometimes this is also called a zero, okay, especially in pre-calculus and calculus. Problem 9. How many roots or answers do quadratic equations have? Well, if you look back at problem 7 and what we wrote, you will recall that we separated part B into 2 problems. And those 2 problems are going to give us 2 answers. Same thing with C, we're going to get 2 answers. Okay? And in E, we got 2 answers. There was a positive I and a negative I. And it wouldn't be any surprise to you that in part D, we would get 2 answers. Now, A, we only got 1 answer. And why? Because A is not quadratic. Okay? However, B, C, D, and E are quadratic. So you're going to get 2 answers if there are solutions. Okay, if there are solutions to a quadratic, you're going to get 2 answers. And sometimes those answers might repeat. So for example, let's say I have this kind of a problem, right, where we separate and solve, but you notice that they're identical. So if I separate this twice and put them equal to 0, I have two identical problems, and when I solve them, I'm going to get two identical answers. Do we have two answers? Yes. But are they identical? Yes. So you might find yourself saying, well, the answer is just -2 because it repeated twice. So Mr. Isn't that just one answer? Well, they're twins. So to be fair, we have a possibility of up to two answers for a quadratic. But be aware of that, okay? So we can have 0 answers, 1 answer, or definitely 2 answers, which is more common, okay? So for your summary, go back to problem 7 and identify the 2 roots for each problem.